This video is going to explore geometry, the theory around geometry, and some basic information about angles. So first of all, every time you see this bit emoji here in the corner, I want you to take down these notes into your maths copy. So these are the basics. We have a plane here, and it's not your typical understanding of a plane, the ones that fly in the sky. These are a two-dimensional surface that has a length and a width, but is no thickness. And then the points in the plane would be A and B. And then you would have a thing called coordinates that would represent A and B on a graph, and we'll look at that in a later chapter. And they're always denoted by a capital letter, and it doesn't have to be A and B, it could be any letter of the alphabet, and a dot beside them. So then we move on to a line. So we know that a line is just a straight line, but these arrows here at the end means that this line goes on indefinitely. And the line is called AB, or the line L. And a ray is the start of a line that starts at one point and goes on forever in only one direction. A ray has only one start point, which is C here, and it can also be considered its end point, and it's sometimes called a half line. So here then we have a line segment. So a line segment is part of a straight line, and it has 2 points, end point and an end point. And it can be measured using a ruler, or there's actually a formula that you can measure this. So this is a straight line segment, and it's denoted by these type of brackets here. Now we move on to this image here, and this is called the point of intersection. So you just take 2 points, let's say one's P and one's R, or 2 lines, one P and one R. Where they cross or meet is called the intersection, and we can call that A. Then you've got the length of a line segment, so you can use a ruler to measure the length of a line segment, or in later chapters we're going to look at using a formula called the distance formula. So if the length of AB is equal to 6, this is written as AB equal to 6, these 2 lines. That means the distance. The distance between A and B, for example, this A and B, is 6. So finally we have collinear points. So this basically means that if 2 points lie on the same line, they're said to be collinear. You could consider A and B, they are on the same line, so they would be collinear. Now we have the different types of angles, and you would have covered a lot of this in your primary school years. So a null angle is just, it has no degrees. An acute angle, less than 90. A right angle is exactly 90 degrees. An obtuse angle is where it's greater than 90, but it's actually less than 180. A straight line is 180 degrees. A full angle or a full circle is 360. An ordinary angle is between 0 and 180. A reflex angle then is it's between 180 and 360. So it's greater than 180, but it's less than 360. And then supplementary angles, 2 angles are supplementary if they add up to 180. So here you'd have a straight line. You can see that it's split. This part of it is 150 and this is 30. And we know it's true because when you add 30 and 150, you get 180. Now that I introduced you to angles, we actually have a way of naming angles in maths. So a vertex B of an angle is always the middle letter in each name. So CBA is angle B, CBA again, CBA. So B, a vertex B means the corner of that angle is B. So let's take, for example, this angle here. Okay, well, let's say I label it now and I say, well, this is B, this is A, and this is C. Okay, well, if I was to name the angle at A, what I would do is I would say, well, angle, and it's given like that, and if you think about it, this is an angle. So it's angle BAC, so BAC, because we always put the angle we're looking for So like in this question it was B, here it's A. You always put the angle that's missing in the middle. So BAC. Let's relabel the diagram then. Let's say we call it X, Y, and Z. Well, the angle then would be X, Y, Z. When we're measuring angles, we always use a protractor. And you basically put this, called your baseline, and your center at the dot where the angle is. And then you measure it by going around in a semicircle, depending on how large or small your angle is. Another important point to note is that you have perpendicular or parallel lines. If lines are said to be perpendicular, they are at right angles to each other. So K is perpendicular to M because they connect and there's right angles. Parallel lines are always the same distance apart, therefore they never meet. So P is parallel to Q because you can see that they're continuously going in the same line, they're the same distance apart, so they'll actually never meet. They will continuously travel in that straight line. An example of parallel lines would be train tracks. Okay, now let's see, can we put our knowledge of angles to the test? What type of angle is at angle ABC? Well, ABC. So what is this type of angle here? Now note that it says type of angle. Not what size is the angle, what's the type of angle? Well, the type of angle is in fact an acute angle. Because it is smaller than 90 degrees. Now, if we were to find the measure of angle ABC, they basically want us to find angle B. Well, we know that a straight line has 180 degrees. If this is 130, angle B must be 50. Because we say 180, take away 130, will give us 50. And therefore, angle ABC equals 50. This question is slightly different. We have a circle. In a full circle, there is 360 degrees. So essentially, they want us to find x. Well, very simply, x will equal 360, take away 155, and take away 80. So therefore, x equals 125 degrees. And we know we're correct because 1, this is greater than 90 degrees. It's an obtuse angle. So we are correct because that is greater than 90 degrees. And when we add 80, 155 and 125, we get 360.